Okay. I hope my screen is visible.
Yes, sir.
Okay. Yes, Prashant. Okay. Yeah, no worries. So today, what we are going to be doing is we are mostly going to go over the content that was there in week two, and yes, it is streamed live. So once we go over the content of week two, I'll be talking about the important points that are there, and post that we are going to go over the activity questions for week two. Yes. Can someone please post the YouTube link if you'll have the channel ready? Thank you, Madhuresh. Okay. So what is happening in week two is, in general, a machine learning project involves a lot of things. So for all these steps that are there, we are first going to build something called as a baseline model, and then we are going to iteratively improve it. So week two, what it does is it covers an end-to-end machine learning project. So all the components that are there in the project, we are going to be seeing it. But at the same time, in the beginning, this can be a little overwhelming. So what I want you to do is just have a look at how things are, try and understand them, and subsequently we can worry about coding it, building pipelines, and all that. So by the end of the course, you're going to be very comfortable with it. But today, what I want you to do is I want you to be very comfortable with the idea of thinking when it comes to a machine learning project. So to begin with, yeah. So here we've taken a data set, but these are the steps in an ML project. So we'll go by them one by one. And this few words of wisdom slide that we have is actually a very important slide when you start working in practice. So when this particular point that says typically only 10 to 15% of time is spent on ML, can any of you guess what is the actual difficult task? I mean, it is directly mentioned in the line below, but what do you think are some of the specific tasks that an ML engineer or someone working in a data science, data analyst field will be involved in? Any answers? Data cleaning, very good. Yes, Madhuresh.
Sir, presenting data in the format so that everyone can understand, means those don't have technical backgrounds.
Very good. That is absolutely perfect. So that is something that is going to come a lot more towards the end, but your actions that you go on throughout the project is something that will influence it. Anybody else? Any other answers? Any specific answers on what other tasks might be involved?
So I think mainly like if we have categorical features encoding them and pre-processing the data before actually putting it in the model.
Right, you're right. Prashant is also right. Pre-processing and collecting data. These are important things. And as we go on, we are going to see a few more important steps. So, firstly, to look at the big picture. So, what does it mean by looking at the big picture? So, one of the primary problems that you're going to face when you come to practice is that you might not know the domain that well. So, typically, there might be, say, data related to healthcare, there might be data related to education, there might be data related to finance. And the way you're going to approach all these problems are going to be very different from each other. So what this says is you first need to understand the objective that you have from this particular exercise. For example, I have healthcare data and say I have collected data of patients who visit a hospital. Now I have data of 100 patients who visit a hospital and I have details of what they were treated for how many days were they present, and when they were discharged. Using a model, your task specifically might be how many of them will come back to the hospital, like for how many of them is there a chance of being readmitted. Now when you do this, not many of us are going to have any understanding of the healthcare domain. So what how will understand knowing the domain help? For example, in the case of say whatever we have mentioned as a diseases or a reason why the person has visited a hospital, maybe someone came for an accident. So they had an accident and they came for getting a cast or something. And it's very likely they might come back after, say, a month or so to get the cast removed. There might be someone who has come for, say, a minor flu or a headache. So it's not that likely that they're going to come back. Right? So this way, knowing the domain is going to help you with things. So along with that, as I think Madhuresh mentioned, so when you are going to present your findings to someone from a non-technical background, it is very important to understand what exactly are they looking for in your particular presentation, which is the general idea of looking at the big picture. Along with that, there are some other things like, for example, select a performance measure, list and check the assumptions. So what do performance measures mean? You might have heard of metrics like error, that is mean absolute error, mean squared error, or if it's a classification problem, you'll have heard of things like accuracy, precision, recall, and so on. All these things you're going to be studying it in detail, but these performance measures are something that is going to help us understand how good our model is. Now, there might be a case where, let me actually give that example. So this is going to be a finance problem. Okay. So finance problem where I want you to detect fraud. Now, if there are 10,000 samples, it is very likely that 9,900 of them are not fraudulent. I'm going to call it NF. And the remaining 100 of them are fraudulent. So can you tell me what such a data is called? There is a specific term for such a data. Does anyone know the term for this?
Sir,
Unbalanced data.
imbalanced database.
Perfect. So both of you all are right. So unbalanced, imbalanced, but yeah, you're seeing the same thing. So here when we have two classes, or it can even be more, we say there is a class imbalance when one of them is very, very less as compared to the other. So now, do you know what problems can occur when we are training on such a data set? Any idea? Okay. Yes, Madhuresh.
Sir, because of this, we won't have much info about how to classify the, fraudulent ones.
Perfect. So what is going to happen is that uh, since we do not have much information about the fraudulent class, say for example, my metric is accuracy. Okay. I'll just write ACC for simplicity. And now if I take accuracy, accuracy is correct predictions divided by total number of predictions made. Okay. Roughly, this is something like this. Now, if we were to build a model that says every single row, every single transaction that has happened is not fraudulent, I'm going to simply put out a model that says class NF for everything. That time we are going to have 9,900 because these many would have been correct anyway, divided by a total of 10,000. And if you end up taking the percent, you're going to get 99% accuracy. But is the model a good one? Can we call this a good model? No, right? So 99% accuracy, but your model has been terrible when it comes to actually identifying the fraudulent transactions. Give me just 1 second. Hello. Yeah. So I hope you got that. So in this case, accuracy is a bad metric. It's a bad performance measure because our model has failed to capture fraudulent transactions. So in this case, we are going to go with some other metric such as be it precision, recall, or F1 score. Was this example clear? Does anybody have any doubts with this one? Okay. So if you don't get anything in this, you can, of course, unmute yourself and ask. But even then, this is the very initial weeks. So it is absolutely fine to not understand everything immediately. Then it comes to list and check the assumptions. Many times we are going to make a few assumptions on the data. It could be things like maybe the features are not related to each other. There is no independence in them. So this is one such example of an assumption. And these will be important when it comes to how we build our models. So this is the idea of a big picture view. And then comes these tasks, which by this point, I think you all are very familiar with. Supervised learning, unsupervised learning, or an RL problem. So for each of them, the way you're going to approach the problem is going to be very different. Likewise, if it is classification or regression, it is going to be different. Single or multiple, it is going to be different. Same way, continuous learning and periodic updates. The way you're going to see continuous learning and periodic updates is if you want to build a model where every single prediction you want it to be right. For example, take a stock market case where you pretty much want to predict every instant what the correct value is. So you want the model to be learning continuously. Whereas maybe I want to know the performance of students across different quizzes. I want to build a model for it. For that, it is quite okay to do periodic updates as and when you finish an exam, maybe I do an update then. Then comes batch and online learning. So that is whether you want to use the entire data in one go or whether you are going to continuously keep feeding in data and do the learning. And as I mentioned, it's totally fine to not understand everything in depth at this point, and it is something we're going to go throughout. So mean squared error, mean absolute error are metrics for regression. Likewise, we have these four things for classification. We just saw an example for the finance data where where using the accuracy for imbalanced data sets might not be that good an idea. We also spoke about assumptions and getting the data. Many of you all mentioned about that collecting the data is going to be an important task. And subsequently, I think we are going to release an assignment where the data is going to be present in multiple files. So, which package do you think, for those of you who have used some of these packages, which one of them do you think is ideal when it comes to gathering data from different sources, combining them, and working with them? Which library do you think you're going to be using the most? Yes, Sahil, perfect. So pandas is one of those. Yes, pandas is one of those which you're going to have to be very familiar with. So there is a lot of data cleaning and data preparation things that you can do using pandas, and it is going to help with collating things in. Do any of you know any functions that you might use in pandas to combine two data frames? Any function that can be used to combine data frames? Okay.
Merge.
Yeah, merge, join. So this way, so here familiarity with SQL will be useful here. So this brings in the idea of you all might have done DBMS or you all might about to be doing that. So knowing basic SQL in this point is going to be very helpful if you are going to be combining data or even filtering some aspects of the data. Once again, if you've not done it, it is fine. There are other ways to do it as well, and it is something I'm sure you all will pick it up easily. So knowing basic SQL is going to help with this. Pandas has also functions called as concatenate. So in different forms, you can join it. Now here they've taken one example. So this is called as the wine dataset, which they've obtained from this repository called UCI ML. And there are different ways to read your datasets. So one such example is read CSV, which might be one of those that you're going to use very commonly. So PD is just an alias for pandas. So when you do import pandas as PD, this is going to allow you to repeatedly use PD everywhere instead of writing pandas as a whole. So pd.readcsv is going to help us read the data set. And then this is an important function. So what data.head does is, can anybody answer data.head?
Use first 5 rows
Yeah.
of the data.
Yeah. So if I wanted the last 5 rows, is there a direct function?
Tail, sir.
Yeah. So this way you understand that a lot of these things are very logical. So data.head will give you the first 5 rows, and as Prashant mentioned, data.tail will give you the last 5 rows. And the nice part about it is if you want some more rows, you can simply mention the number, say 10, and it is going to give you 10 rows. And this is about understanding the features. So here the example is a wine data set. But in general, as I mentioned, this is where understanding even a little bit of the domain is going to be useful for you. Now, if I have something like, say, I want a house prediction data set. Okay, that is, I want to identify the prices of a house. Yes, Samad.
So actually, I was also working on one house prediction data set.
Mm-hmm.
So my question was that like it has now 79 features.
Okay.
So it's taking too long. Like how do I, you know, uh, I don't know. Like if I'm going through each feature one by one and then
Okay.
looking at it,
Yeah,
or
I'll
even
briefly answer your question now, and then we can take it up in detail later. So
sure.
when you have a lot of features, there are some dimensionality reduction techniques. One of them that you might have learned in MLT happens to be principal component analysis of PCA. You can use that to reduce it when there is a sort of correlation between features. Another is to use feature elimination or feature selection techniques. This also helps you bring down features by a lot. And in practice, it actually turns out that 79 features also is sometimes considered to be lesser itself. There are a lot more techniques. I'll cover a bit of it at the end of the session. Yes, Avinash, do you have any questions?
Yes, sir. My question was regarding the pd.head function.
Okay.
So, whenever we want to view our data, most of the time, what I have seen, few of the columns are hidden.
Hidden.
If
Yeah.
someone now has more number of columns.
Yeah, do
Few
you get
columns.
a dot 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 here and then it continues?
Right, right, right. What is there any method
Yeah.
by which
So
you can show?
so you can check this method. Okay, it is called pd.set option, and I think it should be called display dot max rows. Okay. Uh,
Okay, okay. Thank you.
yeah, you
Understood.
can use pd.display max rows, and then write comma, and you can write a number here, say 50 or 100. Same with max columns as well, and it should show it to you. If not, you can also just search for this one directly, display all rows of a data frame, and it should happen. Yeah. So Samarth has also shared it. You can try it. Okay. So yeah, so understanding features is going to help you make better decisions. Like Samad said that he had a lot of features, right? So this way, if I take considering a house prediction data set, so there might be things like, can you give me some relevant features if I want to predict the price of a house? What might be some relevant features? Any guesses, suggestions?
Area.
Okay, perfect. Area is one. Anything else? Number of rooms. Anything
Pro-
else?
Proximity to
Locality.
Okay, proximity to something. So I'll probably put it as location itself. Yeah. Anything else? Okay. So proximity towards places is a good guess. And maybe if the house has a garden or not, does it have a balcony?
Amenities.
Yeah, amenities. If the building has amenities, right? So a totally that not so relevant one might be uh, what are the, maybe okay, color is also probably something people might prefer, but say whether it is, whether the house is whether or the apartment is smoker friendly or not, or pet friendly is sometimes that is there as a consideration, but some of these are totally unrelated, whether maybe it is offering neighboring houses as a sale. So totally unrelated ones that that might be there. Like no parking spaces and all are again something that people might find very useful. Proximity towards airport, hospitals, schools are things that people will find helpful. But then there will also be totally unrelated features many times. Like for example, does the place begin with say some the letter A or something? So that is totally unrelated. Like for example, your IIT Madras campus has three gates called Adayar, Velacheri, and Taramani. So the houses in those areas are not dependent on whether the names begin with V or T or A. So while it is not obviously going to be something like this, sometimes you are going to have data such as say an income prediction thing where you have the person's phone number. Do you think a person's phone number is going to be relevant towards the income that he gets? It shouldn't be, right? So your phone number is just 10 digits at the end of the day, and it doesn't have much to do with the person's income. So, and surprisingly, you're going to find a lot of such features in the data sets that you're going to work with. And it is going to, knowing these things will help you either eliminate the features outright, and in cases where you don't understand what they are, like one of the famous data sets are called as a heart disease data set. So in that, you're going to see things like cholesterol, LDP, and some more features like that. So honestly, I directly don't know what those things mean. So it is a good idea for me to see how cholesterol impacts a person's chance of having a heart attack. So knowing that, automatically it has given me more information to approach this particular problem. Then again, this is the code for it, something that you're going to be getting familiar with over time. So data.columns helps you give out, sorry, yeah, data.columns helps give out the columns that is there in this particular data. You should note that this is only valid when the data that you have is in the form of a data frame. So if it is a NumPy object, then this might not come. The reason I'm telling this to you is these are some practical problems you'll face, and you'll want to correct it as you work. And what does colon minus one mean? This is similar to what you'll have seen in Python. This says give me all the columns except for the last one. And for the label, what do I want? I want data.columns, but this time give me only the last column. So when you do that in this particular example, you have got these many, until here you have got your features, and this one is your label. Is this okay? Is everybody clear with how we have obtained this?
What
Data.columns.
is
Yeah.
this dot value in first?
Yeah, dot values is to show these things as they are, these names to get them. So dot values helps you get the names as they are. Otherwise, I don't remember what exactly object type you are going to get when you put just data.columns with a -1, but values helps extract them. Okay. So far we have seen a function data.head, and now I think the next one we've directly seen is data.columns. Okay, so these are some important ones that when you work with any data set, you're going to want to use. Does anybody know of any other functions which you think will be used in the initially itself? Of course, we are going to be seeing it today itself, but does anybody want to try? Because these are things you'd want to have in your memory as well. Any other functions? Some common functions, yeah.
Null values finding.
Okay, do you know what is the function for finding null values?
Is NS.
Yeah, so isNA is one of them. So data.isNA. So the exact way to write them, so some of them will have this. There'll be a bounded method, so you'll have to check all that. Anything else? Any other ones that you'll use initially?
There is in.
Sorry, isn. Okay. Yeah, data.info is a very good one. We are going to be seeing that as well. Okay.
Also describe.
Describe, perfect. So data.describe is also there. So we are going to be seeing these today itself. But the reason I'm asking is, like I said, it is good to keep these things in your memory. Okay, so directly we start with the data.info, as I mentioned, is an important one. So what this does is it gives you the list of all the columns. It tells you whether there are null values, but there is a catch here. Does anybody know? So this tells the null values, but there might be sometimes that it does not get some of them. So does anyone know when that happens? Okay. So normally, traditionally, you'll have null values written as something like nan or null itself. So, but if it happens to be marked by a symbol, say something like a question mark in quotes, so this is a string object with question mark that is placed. So in these cases, it's very likely that the non-null values will not be identified in this particular column. Okay, so that is something you have to be aware of. And this tells the data type. This is mostly to do with storage. And yes, so this is mostly that. You also have this thing here, 1599 entries it says. Does anybody know a simple function that tells me how many columns and rows are there?
Shape. Data
Very good. So shape, yeah. Yes, Sudhir. Yes, Prashant. So shape is the one that gives you the dimensions of the data. And that is a very important one. Typically, that is one of the first functions I use as soon as I load the data set. Someone else had also mentioned describe. So describe is very important in giving the statistical features. But with these statistical features, there is another catch. So can someone tell me what else can this particular method be used for? So do you know if there is something else we can identify from this?
So it describes standard deviation, mean, count.
Yes, standard deviation, mean, these are directly obtained. But
And
if I
also percentile, and we can see the outliers from it.
Perfect, that is what I was looking for. So outliers. Now, for example, we'll take a look at this particular column, total sulfur dioxide. Okay. So when we look at total sulfur dioxide, the minimum value is 6, then 25% is 22, 38, 62 until 75th percentile. The mean value also happens to be 46, but the maximum value is 289. Compared to the others, it's actually a much higher value. Now, in this particular case, it's very much possible that this is not an outlier, but is actually part of the data set itself. So it's not something to be alarmed about. But in many cases, what we end up seeing is sometimes there will be the case where you'll have 0, 0, 0 in for minimum 25 percentile, 50, 75. But when it comes to max, it is going to be some ridiculously high value, like say 99,000. So these are clear signs that there is an outlier present. And unless you clean those, the models that you build has a very good chance of being skewed because of that. Is this okay? Yeah. So data.describe not just gives you the outright one that it gives you is things like the statistics as we discussed, but the other important hidden sort of idea that we are going to get is if there are any outliers present. Then this is called as value counts. Can someone tell me what this value counts does? Any idea what this does?
How many like samples of each in the data set are there?
How many samples of each?
Each unique value.
Okay,
Count of
yeah. So both of you are right. So this is again going to be very important. So here data.quality. So in this particular data set, quality refers to the quality of the wine. So the values it took were between 3 to 8. And value counts tells you how many of them are present. Okay, so in this case, we have 681 samples where the quality is 5, 638 for 6, and so on until we have only 10 values for 3. So value counts is a very simple and useful method. Yes, Priyanshu.
Sir, in this, how it has picked up like in random? Because I see these are not in order, right? 5,
Yeah,
6, 7,
yeah, but 681, 638, 199, 53, 18, 10. So it is in this order.
in descending order. So is this
Yeah,
always in descending order?
yeah, this will be in descending order. So
Okay.
of course, in sometimes you'll have the case of text values, like instead of 3 to 8, you might have string-based values. So in that case, I don't recollect. I think it should again be in decreasing itself. It is usually in decreasing itself. It is something you can experiment with. Okay. Yeah. So now a histogram. And I think initially someone also suggested that an important part is presenting your insights. And charts and visualizations much pleasing and easier to the eye than simple numbers. With this, can someone tell me the nature of this data set? What pops up when you see this particular chart?
Discrete data set.
Discrete data set, good. What else?
Categorical.
Sorry,
Categorical data set.
categorical. Okay.
Gaussian distribution.
Sorry.
Ga- Gaussian distribution. Maybe.
Okay. About the distribution, fine. Anything else?
Lots of value around 5 and 6.
Yeah, so lots of value around 5 and 6. So we discussed this in the beginning as well. So this data set also is again sort of imbalanced. There are more entries corresponding to 5 and 6 as compared to the other values. So with this chart, immediately so many of you all were able to give good answers about the distribution, about the nature of this particular data set, and the categories, the values it takes. So that is why it is always a good idea to go for as many visualizations as you can. So likewise here again we have plots for the other features. So once again we can talk about the distributions that are there, and we can also run statistical tests on these. Okay. At this point, as I mentioned, if this feels like a lot of things, it is fine. As we go on, we are going to see things bit by bit. So again, these are what they have said. A few are tail heavy. They are at different scales. Like this is the scale that we have on this side. So you can see they are at different scales. This is low values, whereas this was in hundreds. And it also talks about the distributions and all that. Now coming to the idea of creating a test set. Okay. So have you all learnt about this in MLT? So any idea if something like this was covered in MLT? Any answers for this?
The test set is the data set, part of the data that we reserve for testing our model.
Okay. Any other answers? Okay. So we have train, we have test, is there one more kind of data set?
Validation.
Validation, yes. So, does anyone know when we are going to be using these three things? Why do we need these three structures of a train, test, validation?
Train is for training our model,
Okay,
and validation for validating our model,
okay,
and test is to test our models
okay.
accuracy.
Yeah. So, but then normally we would have to be giving a little more described answer. So you're right in the sense that train is going to be for training, validation is going to be for validating, and test for testing. But what is going to happen is when you're given a data by a company, they're going to give you say 10,000 samples. Okay, let's take a simple case of supervised learning and maybe a classification problem. There are 10,000 samples or rows, whatever you want to call it, and say it's a binary classification problem. So you also have this many 10,000 labels as well. Okay, so 10,000 rows plus labels. Now they ask you to build a model and deploy it so that subsequently your model is going to be predicting the label. Now that part that is going to come later is something that is hidden from you. So typically you can think of that as the test data. Okay. For the test data, you're going to get the rows. By rows, I mean the features. But you won't have the labels. Okay. So what are you going to do? So you have your 10,000 rows plus labels and you're going to train your model. But the problem that is going to happen is there is a good chance that your model might simply memorize. So what do I mean by memorize? You can think of this analogy that was explained by a professor once. You can think of training as the questions that your teacher discusses in class. Okay. So these are questions discussed in class. And your validation, you can think of this as like the homework or the problems that you solve from a textbook. So what this means is you're going to try to solve the questions, but if it so happens that you don't know the answer, you can always look at a textbook, learn again, and improve your understanding. And finally, the test is simply like giving an examination, where whatever you have learned using these two things are going to be the important ideas, but you have no idea of what the actual answer is. Okay. So is the difference between train, validation, and test clear? Any doubts with this? Okay. So this way, typically even in the data set that you are given, you are always going to split your training data into training plus validation. So training is where you're going to train your model first, and validation is sort of like a mini test that you take for yourself. It is like checking if you've understood things properly. And finally, testing is the test data is where you're going to deploy your model. You're going to actually see the performance. Now, what does data snooping bias mean? It is a little more involved in the sense that we can also, as humans, introduce bias. Now, you're going to train your model, you're going to use validation, and then you're going to send it to the company. Yes, Samar.
Sir, so like if we split our data set 80% into train, 20% test. So from the 80%, then again we split for validation.
Yeah, so that is something you can do. But typically, like I said, the test data is one you're going to have without labels at all. So that is something we won't have over our control. But as you mentioned, it is again a good practice. That is also something that is done. Some other ones that you'll have heard of, the terms you'll have heard of is cross validation, where again, they are going to break it into more than two parts. And you're going to train on some, you're going to check on some that way. Okay. So what you said is perfectly fine. So if you do not have a, if you are say learning now and you want to try it out on a data set, you can simply take a portion of the data set, keep it away, and then you can do your again train plus validation split and so on. Okay, so that is valid. So here, this particular one, when we are talking about data snooping biases, You have built a model, you have checked, you have done its validation, and you've sent it to the company. Okay, and the company says, no, this is not a good model. This way, you keep sending 10 models, and finally, for one of them, they say it is okay, that this model is fine. So, with this, it is very likely that you have not understood what is required from the model, but simply because one of them worked, you have sort of brought in a bias. Now, even if it worked for this particular test set, for one that we do not know the values, in the future, there might be some other test set, but your model might not perform well for it. Is this okay? It is like, I think at this point, many of you all might have started using, say, the previous year papers. Now, the previous year papers, ideally, you don't know the solutions for it, but then you learn, and then you try your skills in the previous year paper, and you feel that you are learning if you start scoring better. But what if one day the questions are very, very different? That time there is a chance that you might not do that well, right? So if you are very reliant on that. So this is something like that. So this is a bias that the humans can also bring in. Is this okay? Any doubts in this? Yes, Avinash.
Yes, sir. So, sir, I was just wanted to know if my understanding is correct. So, we split the data into test and train set in such a way so that the distribution of test data set and training data set is similar, right?
Right.
So, I'm talking specifically in the case of unbalanced data.
Yeah.
Uh, let's assume I have managed to keep the distribution same for testing the training data.
Okay.
Uh, and then after I applied a oversampling on my training data set.
Okay.
So the distribution of training data sets has changed, right? But the distribution of this data set is the original one,
Yeah.
unbalanced.
Yeah. So there are a few again theories behind that as well. Now, for example, the idea of using oversampling techniques, it might not necessarily always be a good idea. In some cases, when you try out, say, a project or something, you might find that after you use oversampling or undersampling methods, your performance has dropped. Okay. Because the nature of the data is that typically there are going to be very few values. So some other methods that you can use is you can weight those samples. When you're training your model, you can tell it to give importance towards classes where the values have where there are lower number of values. So that is giving class weights. Now, as to
Right.
the problem where you mentioned that the training data you have oversampled and managed to equalize the distribution, but that is still not the true distribution of the data, right? So there is a good chance, even if you oversample, that your model might not learn sufficiently well enough. So these are things you're going to try, which one works. A lot of machine learning practice, once you know the theory, is about trying out different things. So, but yes, test data, you cannot do that. You're still going to hope that either it learned with your oversampling methods or your undersampling methods or with the use of class weights, or you'll have to do some analysis once you build the model with something like feature importances and all that. Okay.
Right. Sure. Thank you.
Yeah. For those of you who are not getting, say, this part that we just discussed, it is fine again. So these are things that you'll find largely in practice, and by the end of the course, you're going to be comfortable with this. Now we just spoke about splitting the data into train and test. So this is a function that they have written using, I think, NumPy largely. But what we are primarily going to be using in this course is sklearn. And sklearn offers us a very easy method, which is to simply write this much. So when you do this, it is going to take in the data that you have. It is going to send 80% towards training and 20%, or rather 0.2, towards test. And when they call it test, this is just terminology. Be very clear with this that there are three things in actual terminology, which are train, validation, and test. So if I write whether I have labels here, this is true for this, but false for this. Okay. So here it calling it test set is just a terminology. But in practice, whatever we are given as a training data set, you're going to split your validation from that itself. And finally, you're going to submit your model for the actual testing. Okay.
Correct.
Then comes, yeah. Is there a question?
The code which was one given below,
Yeah.
this will split the data set in the ratio of 80 is to 20, right?
Yes, 80 is to 20. So 80% will
So,
go to training, 20% to test.
We are giving the input as 0.2,
Yeah.
and it will return in reverse way.
Yeah, no. So this basically, so when you actually see the documentation, we can pass in names of the parameters. So this will be called as test size. So test size is equal to 0.2. So the thing with Python and all is that you don't always have to mention this. So just depending on the ordering, it will automatically consider it. So if for good practice, you can refer the documentation wherein you can write this test size and write as 0.2. So that time there will be no ambiguity. Okay. So
Okay.
it's a
Okay,
good
sir.
question you brought up. So it's very likely that if you just see the code, you can get confused. But I hope it is clear now. Yes, Samar.
Sir, can you scroll up in the?
Oh, in this one, actually, this is the NumPy train test split. The SQL and train test split is slightly different. I have to apologize for it. So here, test ratio and data. So this split train test split is still the NumPy function that is just written above. So the sklearn function, we are going to see it later on. So here, this one takes data as input and test ratio as input, which is why there is a 0.2 here. Okay.
Sir, so my question is that in our original data we have our target variable also,
Yeah.
and so when we're splitting it,
Mhm.
so both our train and test will have the labels.
Yeah, so here both train and test, or rather your validation will have the labels, which is
Okay.
still fine. So because you are going to be training your model on this, and you need to verify your model, right? So for that you need the validation, or here it is called as test set. You want this also to have the labels, so that you can check your answers. This is like solving the textbook questions where you have answers at the back of the textbook or something like that.
Right.
Okay, and it will be much more clear and simpler when we see the sklearn version of this. Then when it comes to sampling, so we spoke about how we have to separate out the training and validation and all that. But there is a chance that maybe what I'm going to do is I'm going to take the list of students and their scores. So first 1,000 entries I'm going to write, say, of those who got S, then a few thousand of those who got A, and it keeps going all the way until, say, whatever is the lowest grade, E or F, whatever it might be. So say it is sorted. Now, if I were to simply pick out the values like this, so first have this as my training and say this as my test or validation, then it is not a good idea, right? So because directly my model is not at all going to be having much information about those who have gotten, say, the lower grades. So the way we can sample is there is one random sampling, which simply randomly takes k% points, not in order, but simply randomly picks. But then we saw the other case where there can be imbalance in the data, where if you recollect that wine data set, there were plenty of, the bar graph looks something like this. For 5 and 6, there were plenty, but for the other values, it was very low. So now if I take a random sampling, there is a good chance that simply because of how many entries of 5 and 6 there are, my training or test set one of them might just contain values from 5 and 6. So what this stratified sampling is going to do is, it is going to make sure that if there were, say, 100 values here, 90 values here, and say 5 and 10 values here, roughly. Okay. So I'm talking about the count here. So the label might be something like 5, 6, 3, 4. Now what stratified sampling is going to do is, if I want to pick out, say, just 20 points, or let me make it easier for myself, I'll say 19, 20, yeah, something like 21 points, roughly. It is going to take the proportion of this whole thing. So in this example, there are 205 points. So it is going to do 100 by 205 into whatever many I want. If I want 20 points, it is going to do 100 by 205 into 20. That way, whatever this value comes out to be, it will have that many entries. So that is stratified sampling. So that way, you're going to have representative of the overall distribution. Is this okay? Yes, Samarth.
Sir, so in this case we had a categorical uh,
Right.
target, but if it's a continuous, like say log of sale price or
Yeah, so
so,
even if it is continuous in the sense is that it is going to maintain the overall distribution.
yeah,
So that
okay,
it does not matter, right? Even if it is continuous, if my original graph is, say, something like this, it can still have smaller samples that follow a similar peak. So it's
okay,
just that the frequency will be lower.
Okay, so stratified sampling will still work.
Yeah, it will still work. Okay, as I was saying, finally we come to the sklearn version of it. So in sklearn, there are these sort of modules. So model selection is the one which contains train test split. So you can call that, and this will simply, previously we saw that we had to write this function to do it. This whole thing is now abstracted to just one line. So you just call this line and your data is split. Okay, so this is train test split, and I think one of you asked about how do we know what the number refers to. So here, as you can see, test size, there is a parameter called test size. So if you write something like 0.2, it is always going to refer to the test size. Shuffle flag. So here I spoke about whether we need to shuffle or not. So in this order of having these grades like this, our model, the split that happens might be bad. So it's a good idea to always keep shuffle is equal to true. And what is random state? Random state is something that allows us to ensure consistency. So it sets something called as the random seed. And what this means is that you're going to be able to replicate your experiments, because even when we do these things randomly, there is no true randomness when it comes to computers. So it is always some fixed approach that it follows. So setting this random seed allows different people to replicate the results of an experiment. Now, this is something that will be useful for you when you're doing your OPP or the online proctored programming examination. So once you finish importing this, okay, so once you finish importing train test split, if you want to know what it does within the Google Colab environment, I hope you all are familiar with Google Colab. If not, you'll be seeing it in the coming weeks, I suppose. So you can simply use question mark and write the name of the method, and it gives a description such as this. And actually there is more, it also gives you an example of how to use it. So that is something we'll see in the OPP sessions as well. And if you all get time, please do explore it. Now this is the train test split using sklearn. Stratified sampling we just discussed here, they have given the same example, where if there is a significant, many examples of class 5 and 6 and can cause a problem during sampling. If we want it to match the overall distribution, we can use stratified shuffle split. So that is stratified shuffle split. Again, it is also in model selection. And data.loc. So lock and iloc are methods that you are going to get familiar with. So that helps us to pick out portions of the data. Okay. So here, when they have used this split method here twice, it has given the train indices and the test indices. Indices are something you can use to identify those specific rows. And then when you use the lock method or LOC method and pass in those, you are going to get the actual values. Okay. And this piece of code that is there here is to verify whether stratified split has done a good job. I'll directly go to the comparison. So yes, Avinash.
Sir, in case of test train split, the shuffle was important parameter. But in case
Yeah.
of stratified sampling, why do we need to use the shuffle method again? Stratified shuffle split, I guess. Yeah.
Yeah,
So,
here you don't necessarily need to use shuffle. So I
uh,
don't think they've used shuffle in this one as well. It is going to pick out things based on the distribution that it follows. So it should be fine to go without shuffle. Okay. And a lot of this, like I said, will be trial and error. So you should not have any difference when you whether you use shuffle or not as much. Of course, you're going to be getting different versions based on your random state and all that. But yes, you're right. So shuffle should not really play a role as such. Now let's come to the comparison. So what does is this is the original distribution. If you use stratified split, this is the distribution. As you can see, for most of them, it is very close. 0.42, 0.42, 0.39, 0.4. Okay. 0.12, 0.12. So this way you can see that if you use stratified shuffle split, whatever sample that you get, the smaller subset that you get, will be very similar to your original distribution. And that is actually the meaning of the word strata or strata as well. So you can check it. A good, like I said, many of these things have very common sense related names. So strata also is something that is commonly used to signify something that maintains the original distribution of sorts. Okay, so this code is again to verify the same. And here I think they show a comparison. So this is between stratified split, using stratified split, its comparison with the original distribution, and random split and its comparison with the original distribution. If you notice, for this particular value, the compared to the original, it is only minus 0.06. If you recollect, 3 was one of those categories which had very few values. So when you use stratified split, its distribution is still comparable to the original. Whereas if you use random, you can see that it largely varies with the original one. There's almost a 50% difference. Is this okay? Is this clear? Okay. Now we come to data visualization. So far we saw a few things. Data visualization, another one of the most important things when it comes to model building, because you're going to see that writing code, especially in this time with something like LLMs, writing code, building models is a very simple task. But actually getting the insights out of it and planning what questions that you need to answer is the more difficult task. And data visualization is one of them that largely helps with it. We already saw in the previous example, many of you all just had one look at the chart and you all were able to answer so many things about the data, which is why I would stress now itself, pay attention to data visualization as well. So it might not necessarily help you or get you a lot of marks in this MLP theory course, but later on when you want to work or in the case of your projects, visualization is something that is going to improve your skill by a huge margin. Okay. Here they first talk about something called as an exploration set. So this is something you can use if you have a very large data set. You can take a smaller portion such that it maintains a distribution, and then you can visualize on that. So it helps with the initial exploration. It gives you a rough idea as to what might be relevant and what might not be relevant. We'll see some more as we proceed. And they also say you can use a copy. This is so that you do not distort the original data that is there. Okay, now we come to scatter plot. Can anybody tell me what we can understand from a scatter plot? Any answers?
Correlation.
The correlation.
Yes, I think both of you all came to the same answer. So correlation is one very nice or important aspect that we find from a scatter plot. So what exactly is correlation? Based on the graph and values, can somebody tell me what it helps us understand?
How related one value is to another.
Okay, we understand about its relation. Anything more about correlation?
Yeah, from this graph, you can see that if density increases, mostly acidity will increase.
Yeah, so this is what I was talking about, insights. So with a correlation value, we might get a number like 0.7 or 0.9 or 1, whatever it might be. But to someone who is not from a background such as ours, which is where someone who has not worked with, say, a lot of techniques or numbers, you would want to present it that way. We observe that as the fixed acidity value increases, the density also seems to increase, or maybe the other way around. Whichever is appropriate, that is how you're going to present your conclusion. So correlation is something that helps us establish that. And this is a visualization aspect where they have colored based on quality. So for different classes, you get different colors. So maybe one such thing you can see is there is a lot of orange points around here. So with this, you can kind of understand that maybe if the quality is higher when both the density and the fixed acidity are on the lower side. Okay, these are just the numbers that we saw again, and this is another important function. Can anybody quickly name 4 or 5 of the important functions that we saw when it comes to exploration? We just spoke about it some time back. Data.head and data.shape are one of those you do initially. Can you name 3 or 4 more? Ones that we saw today.
Describe.
Describe. 2 more.
Data,
Informative.
Okay, data.info. 1 more.
value count.
Okay, value counts. And yes, Bhavana, you were saying?
So I'm saying, not saying.
Okay. Yeah, so perfect. So these things, keep it in your memory. Whenever you load a data set, quickly try it out because it gives you some good information. Now, when you use the CORR function, that is for correlation, it gives you the values. And in this particular one, yeah, which one does has the highest correlation with the, okay, it is already directly mentioned. So you can see, yeah, alcohol content has the strongest positive correlation with quality, and strong negative correlation with volatile acidity. Can someone tell me what this means? A strong positive correlation?
Strong positive correlation means it's going to the upside.
Yeah, so it is increasing, right? So
Yes.
whenever the alcohol content is high, apparently the quality also is seen to be high. Now this was numbers, but I think we can all agree that this is much better looking. Yes, Avinash.
So, sir, based on this correlation parameters, whatever we show in the relationship, can we exclude few of the features which are closer to zero, for which the correlation is closer to zero? Is it a
Yeah,
good idea? What is recommended practice?
absolutely. It's a good idea. I think Samarth had brought up how he had a lot of features when it came to the house prediction data set. If you so happen to find that your now, for example, this residual sugar, at least by picture, it looks like it doesn't have much relationship with the quality. So if you have too many features, it's not a bad idea to just drop it because it doesn't seem to influence. But the word of caution that I will give you is when you see many of your data sets, what you'll end up seeing is that most of your features are more or less, very close to zero, or they'll be very small values. So it's very
Mhm.
likely that will happen. In that case, you'll have to look at some other methods like combining features or doing some kind of transformation and all that. That you'll learn it in practice. But absolutely fair point. If it is close to zero, it indicates that there is not much correlation between the two features. So yes, as I was saying, it is much easier to visualize like this. And the moment we see this, so we know that the lighter it is, the higher the correlation, and the darker it is, the more negative correlation that is there. So quickly I can see that, okay, this value, this value. So these things are all, immediately visible to us, that there is some sort of strong relationship between them. So correlation heat map is also something I want you to use as much as possible in any data that you analyze. Okay. So yeah, the other thing is that the diagonal is one because it is fixed acidity with fixed acidity and so on, and this is going to be a mirror image because the correlation of fixed acidity with volatile acidity is the same as volatile acidity with fixed acidity. Okay. Now this is scatter matrix. We saw a scatter plot. Yes, Avinash.
So, this heat map, was that a correlation between one feature with another feature, or correlation with the output?
Yeah.
What
So
do you?
this is every feature correlation with every other feature. So in this case, for example, I had something like, I think this was an example that the student itself had once suggested. If I were to simply have a feature, say date of birth, okay, or something like that, something you can take date of birth only, and maybe years. This directly will not be applicable, but you get the general idea. The age of a person, and or maybe we can take age and the year in which he was born. Okay. So
Mhm.
these will have an exact one correlation because they both more or less are for the same thing. So
Right.
there is no point in keeping it. And yes, Samar.
Sir, so like what you were saying earlier, that some of the features might have very less correlation with the target variable,
Yeah,
but like still in that case, we shouldn't drop them right away
yeah.
because like with some other variable, they might be
That is
totally.
also true. That is true. It might be influencing some other variable. But it is still okay to explore. So these are things, like I said, you're going to be trying and testing a lot of them. You're going to be doing feature elimination, feature selection, PCA. So these are all valid approaches, but you should know why you're trying something. So if you have a lot of features, if it is difficult to work with, it is not a bad idea to remove those that have very less correlation.
Hmm. Okay.
And then if it doesn't improve your model, you can then again try out some other things. Okay. So this is called as a scatter matrix. This is going to again take it with different features, but it is going to draw a scatter plot for when you are trying out two features, and it is going to draw a histogram for that particular feature. Now for citric acid, it is going to draw its histogram, or rather the counts of it, of each value it takes. And when you compare it with some other feature, it will come as a scatter plot. Okay, is this fine? Okay. Then yeah, so this is the prof is saying the same thing, that exploration will be iterative. This is to get quick insights, and you do not have to be absolutely thorough. That is, you're going to try some things, go on up to building your model, and then you're going to come back and try all these things once again. Now preparing the data for ML algorithm. So previously, I think some of you all suggested that data cleaning we need to do, and in data cleaning we are going to have outliers. So this kind of captures all of them. You have data, you have outliers, you have missing values. Sometimes the features might be at different scales, and the data distribution is not suitable for learning. We'll also see example of that. So these are some necessities for pre-processing. Now let's do a simple theoretical question, something that will strengthen our understanding. Now I have a KNN model. Is there anybody who does not know what a KNN model is? K nearest neighbors classifier. If you do not know, you can raise your hand and stop me. So KNN classifier, and the second one I'm going to consider is decision trees. Okay. So for which of these two models do you think I need to do scaling? Firstly, can someone tell me what scaling of features is? What does scaling mean? Any answers for this? What does scaling mean?
Generally, we either standardize it.
Okay, we can standardizing the data is one form of scaling, correct? So roughly it brings all the features to the same values. So do any of you have any idea for which one we need to do scaling and which one we don't? Okay, so consider this. So I have, let me take the income of a person itself. I have age and say whether he owns a house. This is owns a house and income. Okay. Now I have say three people. One, two, three. This guy's age is 35. This guy owns a house. His income is say 20,000. This guy's age is 36. He owns a house. His income is 22,000. This guy's age is 70. He does not own a house, and his income is 20,500. Okay. So, by first look, which entries do you think are closer to each other in this? Is 1 and 2 close? 1 and 3 close? 2 and 3 close? Let me add
1 and 2, sir.
1 and 2, right? To make it even more, this one I'll say for married, it is true for the first two and false for the third guy. So, does anybody have a doubt that it is not 1 and 2? No, no doubts here, right? So, now if you use a KNN method directly, it relies on distance. So, to find the distance of the first two guys, I do 36 minus 35 the whole square plus 1 minus 1 the whole square. Again, married also 1 minus 1 the whole square, and for income I'll get 2000 square when I take the difference. But if I do it with this third guy, this difference is only 500 square. So his age difference will give me 70 minus 35 square plus 0 minus 1 the whole square. His income difference is only 500 square. This is a little cluttered, so I apologize for that. This is 1 and 2. This is 1 and 3. Do you all see the problem with this?
By calculating this Euclidean distance, the 1 and 3 comes closer. That is not the actual case.
Yeah,
So we need to standardize or scale the feature set.
absolutely. Now, do you get why you need to scale features? So, this is the kind of thought process I want you all to develop when you are building your models.
So
So,
could you explain again?
yeah, I think I should write it better as well. Okay, so person, then let's say age. This was say a job. This is married, own house, and income. Okay, so person A, B, C, 35, 36 has a job. So I'm indicating having a job as 1 and not having a job as 0. This is a purely like a fictional example, of course. So just to illustrate that this is a common problem when it comes to data analysis. Hmm, okay. So do you get this data set? This data set is fine, right? Now in this data set, uh, which like who are closer? Is A and B closer or is A and C closer? Not in terms of distance.
A and B is
Yeah, A and B is closer, right? But if I were to use the KNN model, the KNN model says I have to take the distance between all the features. So I'll do for A and B, I will do 35 minus 36 the whole square, 1 minus 1 the whole square, and this minus this the whole square. So when I take the values, 35 minus 36 the whole square will give me 1 square. The rest of them are all 0. And finally, the income is 2000 square. Is this okay? But for A and C, the same thing, 70 minus 35 is 35 square. The rest are all 1 square. But this difference is only 500 square. So do you realize that this distance is actually lower? Okay. I don't recollect who asked the doubt. But yeah, what you notice is that this distance is lower, and your k nearest neighbors model will actually predict A to be closer to C, even though practically we know that A is closer to B. So this is why it is necessary to scale, because your k nearest neighbors model has not given equal importance to these features. It has simply taken the value and, or rather, it has considered everything equally and not really given any special treatment. Okay. So whereas for decision tree, I'll now actually let you all think about it. So if you'll use decision tree, you're going to end up seeing that it in fact does not actually need to be scaled. Even in practice, whether you fit the model after scaling or before scaling, it ends up giving the same results. Okay. So I hope it is clear. Okay. So what are some steps in pre-processing? Separate features and labels. Yes, Avinash.
just a question. When we go for the scaling, which method should we choose? Should we standardize or normalize? I mean,
That there is no specific hard and fast rule that this is a good method. Ideally, you can try different ones. It could be min-max scaling, it could be normalizing, it could be standardizing. So all these different methods that are there. You can try any of them. Usually, it shouldn't impact so much. Okay, so it's fine. So in practice, you're going to try different methods, which is why we don't really have anything that says, okay, these are the steps that you need to do, and you get a model. So the reason why we still need so many people to work in this field is because a lot of it is getting an intuition and trying out different things. Okay. So handling missing values and outliers. So many times your data can have missing values. In depth of this, I think, should come in a subsequent week, like what methods there are to find missing values and outliers. Does anybody recollect which simple method gives us a quick way to sort of guess that there might be outliers? Do you all remember which method it was? Data dot?
Describe.
Yeah. So data.describe gives you the statistical part. It also gives the different percentiles and the min max. So it's a good idea to identify if there are outliers there. It'll be a quick way, but of course you have to verify it, but it gives you a rough intuition. Feature scaling we just discussed, and then transformations. This is something we are going to see later. So in some cases, using a transformation such as a log or square root might help improve our model performance. This can be related to the domain. Sometimes it can simply be that when you're trying, you find that out. Now, what we just saw, breaking it down into different steps, you get the labels and the data separately. I think someone previously mentioned is NA as a function for finding missing values. So is NA will find whether it is missing or not. And then when you do a dot sum, it combines all of them and gives you the value. So if there were actually missing values, say if there were 3 values of fixed acidity column that were missing, then you would have simply seen the value 3, something like that. Now there was another catch that I mentioned. It will see the nan values, whereas if there was something like a question mark, or if someone had simply written empty there as a string, then it wouldn't have got it. Okay. So for these, normally we combine methods like value counts, and then when you use value counts, you're going to see, okay, A, there are 30 entries, B, there are 15, and suddenly you see there is a question mark with 6 entries. So that way you know that this was a missing one. Okay. So these are the methods, drop NA and drop, and filling these values are called as, sorry, filling them up with some value is called as imputation. Imputation is one of the early techniques that you're going to do. And simple imputer is a class that you can use to fill these missing values. And the next catch is what value is a good way to fill it. So median value is one of those that is commonly used. With time, you're going to learn different methods. For now, you can just take away this much. Your data can have missing values, and you can either choose to drop them if they are very few using drop NA or drop. But if you want to replace them, you can use imputation methods. What are the imputation methods? We'll see it as we go. There are different strategies. One of them is median. As an example, another one I can tell you is you can use a constant value to replace sometimes. If you simply want to replace all the missing values with 0, you can go ahead and do that. Now, dot fit is a method that actually does this particular exercise of filling the missing values. Yes, Sudhir.
Sir, what is difference between drop NA and drop?
No, I mean, there is not specifically. So drop NA is going to drop all those that directly have it as nan values. For drop, I'm not sure. Maybe you can pass it as a parameter to drop any other values. We'll have to check the documentation for that. Okay.
Right.
Yeah, I'll probably just mark it, and we'll verify the documentation when we are going through things. Okay. And yeah.
These missing value imputation method. Should we split the test and train say?
For imputation, you can actually choose to do it before you split as well, because
Okay.
even if test data has missing values, you want to treat it for the missing values. So that will be fine. You
Okay,
can do the imputation and then do the splitting. Then these are some sort of values that you are going to get from it. When you fit this imputer object, after that you can try out these things. So it will tell what the imputer has learned. And then this median function is to directly get the median values of that particular column. And transform is whatever you have learned from the fit method, you can use it to transform those features. This again, subsequently as we go, you are going to understand it better. Then the dot shape function we already saw, it gives the number of rows and columns. Okay. And here, okay, we don't have the whole thing. This I think is what they've used to create a data frame. They've given the features and the columns. Then comes the case of encoding. I think someone had also mentioned encoding. So apart from ordinal encoder, do you all know any other techniques? Can you name one or two other encoding methods?
Sir,
Label
one hot encode.
one
Okay.
hot in.
I heard a one hot and a label encoder. Okay.
So target encoding.
Target encoding. Anything else? Okay. So I think there's also something called as frequency encoding, for which there might not be a direct function, but that is also a way to encode. You can look it up. So these are different encoding methods. Once again, in detailed description of them will come in subsequent weeks. But what this does is, if I have, for a simple example, say I have fruits. In different rows I have apple, banana, apple, and say orange. Now, most of our machine learning models make no sense out of this. They cannot understand string values and they only understand numbers. So for this, we can use different encoding methods. Sorry. One of them might be to directly give it numbers, like apple is say 1, banana is 2. So now again, since we see apple, we give it 1, and we see orange, we give it 3. This is one method of encoding. Okay. The next one we are going to see is one hot encoding. Now this one, it kind of sometimes, like ordinal encoding does something like this. Now here it might feel like it has given an order to apple, banana and orange, whereas apple is not greater than banana or banana is not greater than orange. So there is no inherent order between them. If there was an order, ordinal encoding would have been good. Can someone give me a quick example of where ordinal encoding might be valid?
That
Dictionary words.
this kind of
What words?
There are words for
Feedback,
dictionaries.
sir.
Words of a dictionary. Okay.
The
Any other
feedback.
answers? Sorry, I couldn't hear you.
Feedbacks.
Can you repeat?
Feedbacks, sir.
Feedback, yeah. So by feedback, I'm assuming you're saying bad, neutral,
Yes,
good.
sir.
Yeah. So words in a dictionary, when we say order, that is not the, like, even in dictionary, I cannot say like apple and banana. So apple comes before banana in a dictionary, but apple is not greater than a banana, right? But for this, I can say bad means 0, neutral means 1, and good means 2. Correct. So this, there is an ordering. So in general, this is the kind of ordering that will be there. So in these cases, it is a good idea to use ordinal encoding. Okay. So whereas if they don't have an inherent ordering, if we use ordinal encoding, we are artificially bringing in some sort of order to it. So for that, we can use one-hot encoding, where what one-hot encoding does is it creates new columns. It will say, it will create something called as, say, column apple and column banana and column orange. Okay, I'm using short forms. So apple, previously the first row was apple. So it writes apple as 1, banana and orange as 0. Then was a banana, so it writes 0 here, 1 here, 0 here. Then again an apple, so 1 0 0, 0 0 1. So this is one hot encoding. So if you look at any row, only one of them is hot. So that is why it is one hot encoding. Now here there is no order between the values. Okay. So this is roughly what it is. This is okay for everybody? Got the difference between one hot encoding and ordinal? So these are encoding methods, which the takeaway is you are converting categories to numbers. Okay, there actually happens to be an example on that as well. So yeah, one of them is hot, the rest is cold. The new features are referred to as dummy features. That is because it is you had fruits as a feature. But now instead of fruits, you have fruits underscore apple, fruits underscore banana, and fruits underscore orange. So it is, you can call it as dummy features. So sklearn has one hot encoder in it. And then there is also a talk of embedding, which roughly put, you can just take it as this line, which converts, or rather from the data, you're going to get low dimensional vectors called as embeddings. What it is in detail, we'll see it subsequently. Yes, Samarth.
So after encoding, like after using one hot encoding, does the original column still remain, or
For
like?
that, there is options in the implementation that you're going to use. I think in sklearn or something, you have an option where you can drop the original column. So you can choose to drop the original column and just retain these dummy features or one hot encoded features. But yeah, it is up to you if you want to retain it. Okay. So then comes feature scaling. Most ML algorithms do not perform well when input features are on very different scales. I gave one example of decision tree. Name two models that are based on decision trees. You all learned this in MLT. So can you name a couple of models that are based on decision trees?
Random forest, boosting, and symbol.
Super. So random forest, boosting, bagging. So few of these ensemble methods are tree-based models. So understandably, they are also not bothered whether you scale things or not. Okay. And this is something I later on, when you all build end-to-end pipelines, which you will be doing as a part of this course itself, I want you all to try this out. Try out different scaling methods. Try it out with these tree-based methods and see if there is a difference in score. Okay. Now, then we come to, yeah, so they show different methods. You have normalization, standardization, the methods are standard scalar, and never learn these transformers on the full data set. So what this means is you have different methods called as fit, transform, and fit transform. So these things you want to learn it on the training data, and whatever you learn, the same thing should be used on the test data. Okay. So you're not going to learn from the test data is basically what it is saying. Because the test data is not something you want to look at, right? But at the same time, it has to undergo the pre-processing, but you don't want to learn any new information from it. So if this is not clear, next in the Thursday session when I'm going to be doing some coding, I'll cover that in depth at that time. So now let's quickly finish this. So this is called as a pipeline. This I will say is an important part at this point, like in a sense for this course in terms of OPP, or maybe when you're doing the projects. This is something which people initially struggle with. So what a pipeline does is it helps you to combine everything. Now you had to do imputation, you had to do scaling, and say you had to do encoding as well. Now when you have to do all these things rather than doing one thing, so I have data, and then say I impute it and I get say imputed data, then I scale it and get scaled data, and then I get encoded data. You can see we are going through multiple steps here. So there's a good chance we might make a mistake somewhere. And it is just tedious to, get one after the other reusing the variables. The use of a pipeline will speed up things very much. So you can pass in all these things that you need to do. You can even pass in the features, just the specific features you want to change, and pipeline will take care of it. So it might be an initial block to learn it, but I guarantee it might take you a couple of days to learn it. But once you are very clear with it, it will make your model building very easy. Is this okay? So, like I said, this particular lecture that you have in week 2 gives you a very large overview of what the entire project looks like. So over this week, as you're looking at the content, trying out the assignments, I would suggest that you mark any things that you find difficult and post them on Discourse, or you can even ask them in the live session. And if you're clear with these things very well, your journey in MLP and beyond when you're working with these things will be very smooth. Okay. So that is what this one covers. And then you have column transformer. So as I mentioned, if you want to use only on, yes, Avinash.
Sir, as you said, these scaling should be only applied to the, learn from the training data and apply to the training set, right? But during that pipeline implementation, we are splitting and transforming on the same.
Yeah, so this example, I wouldn't say, this example is just to show how it works. But in practice, you are going to be splitting the two of them. You are going to learn on the training data and only going to update on the, or rather transform on the test data. Okay. This for now, take it as theory at this point, but in the next session, I will show it via code as well. Okay. And for specific features that you want to apply your transformation on, you can use column transformer. So this is the numerical pipeline or num pipeline that we built previously. And num attributes are the features that you pass. So this is just a variable name that they have given. Using this, you can transform or do your operations on just specific features. So it's very comfortable. Try it out on your own. You have so many tools at your disposal. Try and understand pipeline. And if not, we'll also be covering it in the next session. So then comes building the model, arguably one of the simplest things to do. You call a linear regression model like this after importing, and then you say fit, it is done. So at this point, your model is trained. And after that, you want to predict on your test data, you just call predict function. So dot predict will give you the values. So if it is a binary classification thing, say you had values like uh, married is 1, then has a job is 1, income is say some 30,000, and you wanted to predict. If your model is already fit, it will simply give you 0 or 1. This way it keeps giving predictions. And if it's a validation set, you can even measure how good your model is. So that is what they have done here, mean squared error. So these were the original values from our validation. These are the ones that are predicted. Then the formula for mean squared error is used and we get the value. I hope that is clear. So, okay, so here we have the question that you were asking, wherein, yeah, in this case, I think on the test data, they first drop the quality column and then they make a copy of it. They use they use the pipeline on it, then they predict it, and finally calculate the error as well. This is the entire pipeline. So roughly, like just look at this and understand it in a high level. And next week, of course, throughout this week, I want you to code on your own as well. But on Thursday, we'll be doing it a little more in depth. And this is a plot that shows the actual predictions, actual values, and the predicted values. Okay. So this way you can see this, because it's a linear regression model, you're going to get a straight line. And these are the actual values that were there. So you understand that whatever is remaining here is the error, right? So that is what you are calculating with your metrics. This is another example. Here they have used decision tree regressor. Again, you use predict and so on. Okay, here they're talking about overfitting and underfitting models. Can someone tell me what overfitting and underfitting is? Any idea? Anybody can tell me what overfitting and underfitting is?
Sir, overfitting performs well on the training data, but poorly on the testing data.
Okay.
And underfitting performs poorly on both the data.
Perfect. But what exactly is the model doing? Like, why is overfitting happening?
Because sir, it tries to actually learn each pattern closely.
Yeah. So every particular row, it tries to memorize it. So that is what overfitting means. So here, in this particular example, they're telling you that the training error was 0, but the test error was 0.58. So this means that it memorized all the values. Like for example, let's take a simple case. So say weather, vehicle, and say had meals. Okay, this is for say a cricket match. So had meals, yes. Weather is sunny. vehicle is they are going by public transport. Okay, and this variable is whether they will go to play or not. And the next one is no for means weather is sunny and public transport again. Here they will play, here they will play, and here we will again have something like yes, sunny, and own vehicle. And here they will say not play. So now if I were to build a decision tree on this, so what it might end up doing is, so first it will check whether it is sunny. Okay, something like this. I should write it better. So it will check if it is sunny. If the answer is yes, or rather I should say whether, since anyway all of them are sunny, I'm going to put weather equal to sunny, and I'm going to go to the next question, which is meals. So now for meals, there are 2 yeses and 2 nos. If it is yes, there is an entry. If it is no, there is an entry. So again, it does a box for each of those entries. Likewise, same thing with public transport. There is another split that keeps happening. So what I'm kind of trying to say with this example is, for every particular row that is there, your tree is going to keep expanding till it makes sure it has the exact answer. So now if I say in this particular session, if a person has asked say more than 5 questions, I have the names of say some people randomly. But if my model were to say, okay, Avinash has asked me 10 questions, Samarth has asked 7 questions, and Sudhir has asked me 3 questions, something like that. So that means my model is, rather than generalizing, it is for every particular row it is trying to memorize, which is what has happened in this case. Now these I have tried to give a few generic examples, so it might have thrown you off a little. But in practice, this is what happens. Even if there are 1,000 rows, if you do not control your decision tree, that is, if you let your decision tree keep expanding, it can make sure that the error is 0. Okay, that training error. But when it comes to the test error, suddenly it does not know the answers because it has only memorized, which is why it is going to get a high error, which is called as overfitting. Okay, I hope overfitting is clear. Any doubts with it? Okay. Likewise, underfitting happens when the model does not learn enough. So now this linear regression model we saw. Okay, this linear regression model, for example, say our original data values, let me use this color. Say it followed this particular pattern. Are these new dots visible? I hope they are. Okay. So this is some sort of a polynomial, right? So if you use a linear regression model, something that just predicts a line, no matter how good that line is, it will never match a curve. So in that case, we can call it underfit models. Okay. Overfitting and underfitting will be a common problem in your model building. So you'll have to be very aware of it. Then comes the idea of cross-validation. So cross-validation is where you break the data set into multiple parts. So rather than having one training and one validation, if this is my entire data, I break it into say 5 parts. So this will become 5-fold cross-validation. So I might train it on 4. I'll train and validate or verify on this one. And in the next run, I'm going to use these 4 as my training, and I might use this as my validation. So what this helps us do is, so in the previous MLT course, you learned about different methods. But here, in practice, when you do, you're going to see that there are plenty of something called as hyperparameters. Does anyone know what hyperparameters are?
Like it's outside of the like C.
Okay, you're roughly right. So hyperparameters are something that you cannot learn from the data, but something that you have to keep trying different things and figure out. For example, in the case of decision tree, depth of a decision tree is a hyperparameter. So I can say, if I say depth should be equal to 3, then the decision tree can ask no more than 3 questions. So it tells it, model, you ask only 3 questions, make sure they are your 3 best questions, something like that. But if I have depth like 10, then it can ask 10 questions. It will try to, for every single value, it will try to get the correct label by expanding the tree. Okay, this also we'll see later as we go on. So that those are called as hyperparameters, and hyperparameter tuning is an important part for which cross validation is something that helps. So if I have, say, setting, so hyperparameters, I'll call it HP1, 2, 3. Okay, HP1, HP2, HP3. So this might be something like depth. This will be something called as minimum leaf split. Okay, your decision tree has something like this. That basically says if you want to make a split, how many values should you have? That way it will have some more features. So for depth, I'll give 3. For this, I'll give 10. For something else, I'll give some other value, say 30. And then I'll use cross validation and see what score I get. I got, say, something like 0.58. Next time I do, I'll change the setting to 5, 7, and 20 or 25. This time I got the score 0.7. So this is clearly a better one. So through cross validation, we have found that this set of hyperparameters are doing better. Okay. So more on hyperparameter is also something that we'll see. So linear regression CV. So this is for a linear regression model. They are applying cross validation. They have passed in the model. And what is the scoring? We are measuring on mean squared error. Same thing with decision trees, with random forests. Yes, Avinash.
So I have a question on mean square error, the metric
Yeah.
measure. In case of percentage, it's very easy to
Sorry? In case of?
if the performance we are measuring in terms of percentage, so it's easy to understand. But in case of MSC, let's just take example of two models. Let's assume for model one, my labels were in a 2 digit.
Okay, you're saying if the error is like, say, 30, 1000, how do you compare?
No, sir. For model one, let's assume the correct value was 90. I predicted 89.
Okay.
So when I will calculate the MSC, it will be 1.
Yeah.
Let's assume the single data point.
Yeah.
The model 2, if the label was 0.9 and I predict 0.8, the MSC 0.1.
Yeah.
Which model 1 or model 2, which is better?
So, yeah, so
answer?
this is firstly because these two are in two different scales, right?
Right.
So you can't directly say that this model is better than the other. So it is going to depend on its scale. So that's what in practice, sometimes the value of your error might be in thousands. But is that still a good one is up to question, because if the baseline for that in that particular setting, if I'm predicting income, I cannot expect you to predict income to the dot, right? So his actual income might be something like 32,543. If you predict, say, 32,000, it is still a pretty good model. So it is going to depend on those specific data points, and based on that, you get a rough idea as to what is an acceptable error value. Okay, there is no hard and fast rule as to which is good and which is not. And between the same two models, when you compare, if you get one of them to give a lower error than the other, clearly the one that gives a lower error is better.
Right. Thank you.
Okay. So this is what do you do when there is underfitting and overfitting. So these are some solutions to it. Right now, in the interest of time, I'm not going to explain them more in depth. But yeah, these are methods that you can use to improve it. Then comes fine-tuning your model. I just spoke about different hyperparameter settings. So the method that is used is grid search CV. So grid search CV basically says you can take different combinations. Like, so for random forest, n estimators is how many decision tree models you want to try, how many features you want to try in one go, and yeah, the other one is bootstrap, whether you want true or false. Okay, here it is building two different models, but number of estimators takes values 3, 10, and 30. So this means first time when it does cross validation test, it is going to take 3 estimators and try. The second time it is going to try with 10, then with 30. Whichever gives you the maximum score, it is going to tell that is your best feature. Okay. So I am slightly speeding up here. So when you do a grid search fit, this is the best params it gave. Maximum features as 6 and n estimators as 30. Okay. So this tells you that this is the setting that you need to use in your model to get good scores. So does this feel like I'm speeding up here? Do you all want me to explain this a little more in detail? Yes, Avinash.
So regarding this hyperparameter tuning, I've seen two method, grid search CB and
Randomize, yeah.
randomizer. Which one would you suggest to use in
Grid
practice?
search CV, you can do it when you have, say, a lot of compute. That is, if you are able to run the model for very long, then you can try grid search CV because it will try out all combinations. Randomized search CV is a good starting point. It tries out few values in that particular range. Like say you want to know whether your random forest should have 5 decision trees, 10 decision trees, 50, 100, 200, 300 and so on. If you use a grid search CV, it will end up training a lot of models. So you'll see that it will take 3 to 4 hours for one model to be trained. Whereas if you use randomized search CV, it will only pick up a few of them. It will try for a few of them and tell you, okay, in these many, I found that 10, using 10 decision trees was better. That way, subsequently, you can ignore the 200 and 300 and you can use grid search CV for values 10, 20, 30, 40, something like that. Is that
Got
okay?
it. Always better to try the grid search CB, the whole list,
Yeah.
and choose out of that. Sir,
Yeah.
any comment on the Bayesian optimization when we should use the Bayesian?
Yeah, this I am. It is not there as a part of this one, and right now I don't think it would be a good idea to cover it.
Okay, thank you.
Okay. So mostly for your course, you are going to be using randomized and grid search CV. So then is the evaluation on test set. We spoke about having different train, test, and validation. So here this is testing on that and getting your score. And you get this score, say 0.35. And then you can check using SciPy methods the confidence interval. This is something that you should know, something that you're going to be using later, but not necessarily very important at this point. Then is presenting your solution. This is highlight learnings, assumptions, document everything, visualization. This is what I told, that you're going to be working with people from a non-data and tech background. It is important that they understand what you're presenting. So finally is launch, monitor and maintain your system. What that means is your model as it runs, maybe in 6 months time, things have changed. So this group of students that we had, in 3 months, they started, say, they changed their studying habits and started, say, something like group study, regularly preparing. With time, you're going to see that the scores that they get are, say, much higher. That time, the model that I might have trained previously on their performance might not be valid anymore. So which is why I have to train a new model. In the case of say fraudulent data, maybe in the past 6 months, we brought in a new policy to identify fraudulent transactions. Because of that, maybe the number of fraud transactions have significantly decreased. So in that case, your model will not be performing as well anymore. So that time you'll have to retrain your model. So that has to do with monitoring, maintenance, launch, and stuff. This is not something we have necessarily covered as much in our course, but this is something you'll be doing a lot more in practice. Okay. So with this, I've covered the major crux of the week 2 content. So in the remaining 15 minutes, since the session ends at 10, in the remaining 15 minutes, I will quickly end up covering the activity questions as much as I can. And in the Thursday, we are going to be, on Thursday, whatever is remaining, we will cover it, as well as go over some interesting practical data cleaning and assignments. Okay. I hope you all don't mind. I'll quickly go through the activity questions. Is that okay? Or do you want me to do it in the next session? Fine, we'll start, and in case we take time, we can maybe do it in the next session.
I believe we can start it session, sir. We have one.
Sorry?
I think we can start in the next because we have one two left.
Yeah, we have 12 minutes. I get it, but I'm positive that you all are going to be answering very quickly. I will stop at 10 p.m. Until then, whatever we can, we'll quickly do it. Okay. Okay, but you all will have to be answering for me. Yeah, I hope my screen is visible. So let me actually go for this. Okay, is my screen visible? Can someone confirm? Okay.
It's visible, sir.
Yeah. So the first question, what is data snooping? Or rather, which options do you think are correct in this?
First is the bias in a test set.
Okay. Any other option?
Increases the risk of.
Okay. So leads
Yeah.
to bias test. Yeah.
So what is meaning of false positive?
So false positive is, simply put, it is when the model falsely predicts it as positive. So here, this, I hope the first option is very clear. This is because it has seen what is there in test data, and then it can kind of lead to it memorizing in some sense, which is why it is a problem. And risk of false positive is kind of associated with the same thing, wherein maybe in general, so in general, if it rains, say you are not going to go to play cricket if it rains. But in your data set, you had one entry that said that even if it rains, you're going to go play. Okay, it's just some one specific entry like that. But if your model is kind of like overfit on that, if it has already seen it, then it can be a false positive where it predicts that even if it rains, you're going to go play. Okay. Sorry, this kind of helps with the, or rather, this kind of leads to the model making assumptions that are not true. Okay. Second question, which options are correct in this?
Second option is correct.
Okay. Any other?
Third option.
Third option, right? So as I mentioned, random sampling will randomly pick k number of samples from the data set, whereas stratified sampling ensures that it is representative of the overall distribution. Next, is this true or false? Stratified sampling gives us test distribution closer to the overall distribution as compared to the random sampling. Is this true?
Yes, it is true.
Okay.
True, sir. I think we saw that.
Yes. So we saw that table as well. So yes, if anybody, if you have doubts at any point, please feel free to stop me. Okay, a standard correlation coefficient of plus 0.98 represents.
Positive.
Yeah, a strong positive correlation. Any doubts here? Okay. Why is it a good idea to create a copy of the training data?
Option.
So,
Yeah. Ravi, I think there is some static noise on your microphone. Can you please mute yourself? Okay, thank you very much. Okay. So Matplotlib and Seaborn are used for which of the following? This one we did not specifically discuss, but do any of you know which one it is used for?
data
Visualization.
Superb, yeah. What about data pre-processing, loading, and manipulation? Which one would you suggest?
pandas.
Yeah. So pandas
NumPy and
is
pandas.
yes. So NumPy, pandas, sklearn, we use all three of them for these things. No linear correlation between features is demonstrated by which of the following correlation
Zero.
values?
Zero.
One is seen. When is one seen?
Strong positive.
-1.
Strong negative.
Strong negative.
2.
None of them.
Yeah. So 2 is not really possible. A heat map can be used to visualize correlation matrix.
True.
Yeah, this is fine, right? We saw this. Okay. The is NA function is used for which of the following?
Option E.
Okay. Then which of the following methods from pandas may be used to drop rows?
Drop,
First and second.
First and second. If you all don't know this by heart now, don't worry. As you go on, you'll kind of remember these things. sklearn provides simple imputer for filling up missing values.
True.
True.
Fit transfer method on ordinal encoder object is used for which purpose?
Convert
Convert
it to numbers.
Yeah, convert text to numbers. Encoder, if you remember that apple banana example. So if it is present as text, it gives it to you as numbers.
Sir, previous question's answer is true or false?
Oh yeah, it is true. It is true. I just didn't see
Okay.
that the options were reversed. Thank you for mentioning. So scikit-learn provides a pipeline to line up transformations in an intended order.
True.
True.
right. True.
Good pace. Okay. Which of the following can be used for evaluation measure of regression models?
Mean square.
Okay, what is a pipeline?
Used for ordering the
Just the pre-processing. Cumulatively, you can perform all the pre-processing.
Right. So it is not just for pre-processing. It can also later on you'll see even model fitting, your grid search, everything you can bring in a pipeline. So as one of you all mentioned, it can be used to order things and get things done in a sequence without you having to manually intervene much. What about confusion matrix?
Find the
Sig-
accuracy.
For
class-
classification.
Yeah. So when it comes to classification problems, confusion matrix will tell you how many of the samples of your data have gone into which of the classes, or if they have been misclassified, to which class instead it has gone to. This you'll again see in depth later. Cross validation provides a separate MSE for each validation set. True or false?
True. True.
Okay. This, if you have not seen it yet, as we go on, you're going to be seeing it. Building a model on top of another model is called
ensemble learn.
Ensemble learning.
perfect. So some ensemble learning methods. Any suggestions? Which what are some ensemble
Random
methods?
forest.
Random forest.
Random forest.
Tagging boosting.
Perfect.
Add a boost.
Yeah. Okay. What is the remedy for underfitting?
To
Less
have less
constraint.
constraints.
Less constraints or
Yeah,
regularization.
less constraints and regularization. So I showed you the example where the data can follow a curve, something like a polynomial. But if you fit a linear model, it is like I'm constraining the model to be linear. So if I remove that linear constraint, then automatically my model might fit better. Okay. In depth, we'll see it again as we go subsequently. And any of these topics, if you all need more information now, you can even post it on Discourse. Or you can also bring it up. Next session, probably I'll give the first 15 minutes to discuss. Okay. Grid Search CV is a part of which library?
Scikit-learn.
Yeah, scikit-learn. Which of the following are hyperparameters in random forest?
Number
First
of
two.
estimator or
Okay.
maximum.
Anything else?
Maximum number of.
Okay. So what these are also something we'll see. Number of estimators, like I said, a random forest is a collection of decision trees. Number of estimators tells you how many such estimators you want within a random forest. Maximum number of features is how many features you want to consider at once. And okay, what are precision and recall?
Classification metrics.
Yeah, they are evaluation metrics for classification problem. Initializing grid search CV with refit equal to true retrains the best, it should be retrains. The best estimators on the full training set. Is this true or false?
True.
Yeah. So this again you have to try it out on your own. And for a large hyperparameter space, it is desirable to try which of the following options. This one we discussed.
Randomize.
Perfect. Okay. So I think activity 6 and 7 will be from the two slides that I did not discuss today. I'll probably discuss it in the beginning on the next one. But if you all know, you all can answer. We can finish it since we have 2 more minutes. Different types of SQL objects.
Estimators. Predictors.
Okay. Okay. So this we'll see in the next anyway. This one we've actually seen. Can you guess which of them are correct?
First one's correct.
Okay. So what predict method does is, given an input, it tells you what the prediction should be. For regression, it will give values, like a continuous set of values. For classification, it might give 0 and 1.
And the last one.
And the last one?
Last one.
Okay. What about any other?
Third one is, I guess, grid transformation.
We'll come to it. The function of sklearn.linear model is to implement what?
First one, classical algorithms.
Yeah, so linear model has linear regression and all that within it. For k nearest neighbors, there is one thing called as sklearn.neighbors. Multi-class and multi-output, it doesn't have much specific to do with model building specifically. For naive Bayes, what do you think it is?
Option 2.
Yeah, this is option 2. One such hint that I can give is usually it will be separated with an underscore and the naming will be consistent. So both of them are small letters or lowercase. This one is a generation part. So make blobs. Okay, in this I'll give you the catch. So what it is it says there should be 3 centers. So because it says 3 centers, the values that the label will take 0, 1 and 2. Okay. Which of the following is a supervised learning problem? So supervised learning problem is one that includes labels. So which one do you think it is?
Third one.
Okay.
Bank, yes.
What about this one? Which of them will be a regression task? The first one says recommend. Yeah.
Third one on
predicting rainfall is straight.
Predicting the rain.
Yeah, both of these are regression, right? So the first, what about the second one?
It is categorization.
Yeah, classification problem where you want to put it into 3 categories. Now, this you all can recollect from MLT.
Both are false.
Okay, both are false. We need to divide the sample into train and test because. Which one do you think is correct?
Last one.
Okay. Which function is used to fully describe the data set?
Shape.
Last one.
Okay. So dot shape tells you how many rows and columns there are. Dot head gives you the first few rows. This I don't think it exists. And DESCR, description, is the one that gives a large description. So here I think we'll see a few misses. So which is one of them.
I think in regression one, I think
yeah.
In regression question, I think
the score method is one that measures the quality. So this one that is there. And regression one, I think we have marked both of them. Yeah. So bank and predicting rainfall, this is there. So yeah, I understand this was a little fast. So this particular activity, I also didn't cover it. So 7 also, I'll do it in the next session. I'll go through the content also for you all. In the meantime, yeah, this is the final closing part. How many of you all have done the practice assignment 1? Can I get a show of hands? Okay.
Practice assignment 1 from week 1, sir?
No. Of week 2, there is a practice assignment 1. Okay. So what about the second practice assignment of week 2? There is one more practice assignment that was released today.
Yet to be done, sir.
Okay. So on Thursday, I'm going to be covering those. And they are mostly on EDA. So especially the second practice assignment is a lot on EDA and pandas and Python related stuff. It is on a movie data set. And I would say it is not very easy. It is something that will take some time. But I think it is something you should explore. Okay. So on Thursday, we'll go over everything that is there in that. In the meantime, if you all have any questions, also make sure you note it before the session, post it in discourse if necessary. In the beginning, we'll cover whatever was remaining, the last 2 activity sets. And then we'll go on to the direct coding. So next session will be a coding related one. So you can practice on your own a bit also, and we'll work out on a nice movie data set. Okay. Any other questions? Yes, Madurai.
Sir, my means MLT was not my one of the strong subjects. So
Okay.
I feel